Okay, so in one of the other presentations, you noticed that we tried to graph a linear equation, and graphing using the table method gave us a point that was a decimal. And while that point wasn't that difficult to estimate, they can be very hard to estimate if those decimals end up getting smaller and much less nice. So there has to be another way to graph a line, especially if it's in the form like the one listed above. So what I'll say that's very important is in the equation above, we notice that the x and the y are both on the exact same side of the equation. That would be called standard form of a line, when the x and the y are on the same side of the equation. And what we can use to graph this equation is we can find the intercepts. So we can use the intercept method of graphing this line. When I say the intercepts, what I mean are the x and the y intercepts of a line. So let's, for example, say that we draw a line. Now keep in mind that this line does not represent the equation from earlier. This is just an arbitrary line that I'm drawing. The nice thing about this line is that this line has both an x and a y intercept. I notice the x-intercept is the point right here where the line crosses the x-axis. I also notice that the y-intercept is the point up here where the line crosses the y-axis. Now, there's something that every x-intercept has in common. And if I look at that point, and if I picture any possible x-intercept, which will be a point that's on the x-axis, I know that every single one of those points will always have the same value for their y. Every one of those points will be some random number, comma, a 0. So that's extremely important to realize, is that the x-intercept always has a 0 for the y value. Similarly, looking at the y-intercept, I know that any point that is on the y-axis must have a 0 for the x value. So keeping that in mind, I can take the equation here and I can find the x-intercept and the y-intercept. Now to find the x-intercept, realize what we said earlier. Oh, the y is 0. So what I'm going to do is I'm going to write my equation 2x minus 3 times 0, I'm plugging the 0 in for y, so 3 times 0 is just 0, so 2x equals 6. Essentially, I've just blocked out or covered up the term with the y. Solving that equation gives me x equals 3, so my x-intercept is 3, 0. Now finding my y-intercept is done very similarly, except this time, rather than making y equals 0, I'm going to make x equals 0. 2 times 0, I'm plugging in 0 for x, 2 times 0 is 0, so I'm not even going to write that term. However, I do have negative 3y equals 6, so I'm going to have to divide by negative 3, and I get y equals negative 2. So my y-intercept here is 0, negative 2. So now I'm simply going to plot my 2 points at 3, 0 and 0, negative 2. I'm going to connect those 2 points with a straight line, and I'm going to put arrows at the end of my line. And that would be a much easier way to graph the equation 2x minus 3y equals 6. Now, the other convenient part about the equation 2x minus 3y equals 6, other than the x and the y being on the same side, is if I look at the term without a variable, if I look at the 6, what's really nice is that I know 6 is divisible by 2 and negative 3. So looking at the 6 again, I'm looking at the other coefficients of 2 and negative 3, and I know that 6 is divisible by both of those terms. That's another clue to us that the intercept method might be the easiest way to graph. So let's try a new equation. 4x plus 3y equals 12. I'm going to abandon my table method. I'm going to use the intercept method because I notice that x and y are on the same side. So this is an example that is in that standard form. And then a quick look tells me 12 is divisible by 4 and 3. So this is going to be a very easy intercept method problem. So I'm going to find my x-intercept first, and in order to find my x-intercept, I'm going to again make y equals 0. So that gives me the equation 4x plus 0 equals 12. Some simple division tells me my x-intercept is at 3, so my first point is at 3, 0. Now I'm going to find my y-intercept. For my y-intercept, I'm always going to make x equals 0. And keep in mind, it's no coincidence that we're looking at opposites. So when I find my y-intercept, I make x 0. When I find my x-intercept, I make y 0. So I'm going to make x equals 0. 4 times 0 is 0. So 3y, and it is positive in this case, equals 12. I'll divide by 3. I get 4. So my y-intercept is 0, 4. So all I would have to do would be to graph those 2 points and connect them with a line with arrows at the end. And that may be a much easier method than to create a table of 3 random points.